Hello, Dr. Groh. I'm an online student living in Tacoma, Washington. My name is Kathy Attebery. I'm a construction manager for the Boeing Company, and I have chosen one of Boeing's major projects for my productivity analysis, the Boeing 737 Customer Delivery Center. The 737 Customer Delivery Center is located at Boeing Field in Seattle, Washington. This is a $60 million project, includes the teardown of an existing structure roofed by a 90,000 square foot building next to the flight line. This project has some interesting features, including 3 jetways for customers to pick up their new 737s. This is a design-build contract with Lease Crutcher Lewis as the prime GC and DLR as the designer. The project broke ground in March of this year and is scheduled to complete second or third quarter 2015. The Boeing Company launched a new Go for Zero safety program in 2014. It's not just a focus on safety, but a challenging shift in culture. For this project specifically, Lease Crutcher Lewis, the general contractor, put together an investigative team to figure out why Boeing projects in particular are the safest projects in their portfolio. Remarkably, for the 737 CDC, there have been only 3 minor incidents to date. For my activity analysis, I made 575 observations over 5 days and at various times. I used 8 categories of work classifications, and I collected other metadata such as weather and site conditions. Currently, the project is open steel structure and the pan deck for floors 1 through 3 are completed. I started my activity analysis during the MEP rough-in phase and at the tail end of some of the concrete forming and removal of those forms at the ground level and roof penthouse levels. Simultaneously, there was some dirt work and utility installation occurring. At this time, no photos have been allowed. Here is an example of an activity log I used to capture data. The log captures number of workers, type of work observed, and other metadata such as weather and temperature. Calculations are then based on data observations that given day. I tabulated the data and results show 39% direct work, with the majority of work at 52% performed as support work and 9% observed and classified as delays. If we look closer at the summary, I've also illustrated a further breakdown of support work to include the category of general support work. I created this category to capture some of the efforts related to the rain and wind cleanup, separate from other support work such as prep and instructions. In general, the analysis itself revealed 2 opportunities that really stood out for improvement: time and wait time. The site consists of 4 stories and 4 flights of scaffold stairs positioned within 500 feet of the nearest job box, but oftentimes the work zone for the day was at the furthest point. I also observed a lot of waiting for materials delivery, waiting for support crews to clear the deck from rain. In general, I was surprised by the amount of waiting. For my activity improvement and crew balance analysis, I chose to study the exterior pathway lighting installation that was happening near the CDC facility. This activity included 5 tasks to complete 1 cycle at 13 minutes. The activity was installing electrical conduit in an 8-inch trench along a walking path of 29 bollard lights. The conduit required 2 sweeping 90 bends, modified rebar cage installed over the top, and conduits tied to a position ready for concrete pour. The repetition on this was times 29. The chart illustrates the average of 5 cycles used to create the baseline time for the activity. Results show only 31% crew effectiveness and 69% room for improvement, with a 9 crew member completing all 5 tasks. As you can see here, I thought there might be an opportunity to create a mobile work zone and small rain shelter over the work area. If we were able to improve proximity to the work zone and provide shelter, we have the opportunity to not only reduce the number of crew members, but to increase morale. Here's an example of balancing the crew to maximize effective minutes and crew utilization. By decreasing the crew from 8 to 3, consolidating the work zones, and sheltering the crew from the elements, we were able to reach 70% crew effectiveness. This chart represents the comparisons before and after crew balancing. You can see the variability in crew size ultimately demonstrates fewer effective minutes and more wait time. The risk with this approach is the crew stamina and possibly schedule. If this were a consolidated schedule, there may not be enough crew to complete the full task in the time allotted. The advantages to reducing the crew is that everyone is working together, common tasks are grouped, and the sequence and flow is less disrupted by the preceding task. Overall, the productivity analysis as well as the crew balance activity demonstrated for me the level of planning required by a site foreman to be the most effective and productive, and that actually recording the observations gives you the opportunity to look at the raw data and identify potential flow and capacity issues. I was most surprised by the support work versus direct work during the activity analysis. Even though everyone is working, the level of actual direct work may be considerably lower than expected.